Methods of transistor biasing. The three major biasing circuits are: first one, the fixed bias or base resistor method; second one, the collector to base bias, that is the feedback resistor bias; and third and the most important bias is the potential divider bias. The third one is the potential divider bias, which is the most important biasing, because the purpose of transistor biasing is to obtain the most appropriate values of IC, IB and VC, that is zero signal collector current, zero signal base current and the collector emitter voltage. The particular set of values, DC values for IC, IB and VCE represents a particular point in the output characteristics of the transistor, and that point is called as the quiescent point or operating point. To obtain a suitable operating point, we are using some circuits, and these circuits are termed as these biasing circuits. In fixed bias method, a high resistance RB is connected between the base and positive end of the supply. Consider a common emitter transistor configuration. Here, emitter is grounded and input is given to the base of the transistor. Okay. Here, a high resistance is connected to the base. This is the high resistance RB, which is connected to the supply voltage plus VCC. This and the collector is connected through a resistor RC. Now, this input voltage VCC will provide the necessary base current and it flows through RB. Now, the base emitter junction, this is the base, this is the emitter. This base emitter junction is forward biased, that is the input junction is forward biased, which is the required condition for faithful amplification. Let's go for the circuit analysis. We are giving input to the base and emitter and taking output across the collector and the ground, or collector and the emitter. Okay. Let IC be the current flowing through the collector, and which is the zero signal collector current. We know that for a common emitter configuration, beta is equal to, current gain is equal to IC by IB. From that, IB can be represented as IC divided by beta. Applying Kirchhoff's law to the mesh here. This plus VCC is the biasing voltage. Here this voltage is dropped across this RB, that is IB into RB, and the base emitter voltage. So the Kirchhoff's law, applying Kirchhoff's law, we can write this as the conservation equation of voltage as VCC is equal to IB into RB plus VBE. From that, RB is equal to VCC minus VBE, the whole divided by IB. Okay. Usually this VBE is very small and hence we can neglect this VBE. Therefore, the base resistor, the value of base resistor RB is equal to VCC by IB. For a given value of VCC and IB, that is for a given applied voltage source and for a given base current, this base resistor value will remain constant. Hence, for this reason, the biasing circuit is termed as fixed bias circuit.